I think more long term, that second sub-bullet point is speaking to this sense that mathematics carries its ideas well enough under its own steam a lot of the time without the need for human language. The symbolic system of mathematics does a lot of the work. And then the third sub-bullet point, the mathematics texts I found myself encountering were challenging for me. So that's a little bit of the early stages some years ago now, but the macro level, of course, is, as with Kostas, as Kostas has just said, how to bring these two worlds together, academic literacies, academic language, textuality into mathematics. So that's where we started off, respectively, and a little bit now about our development. Back to Kostas.
So, as I said, my initial assumption was that language wouldn't be as important in my mathematics lectures, precisely because I can write all the mathematics on the board using mathematics notation purely. However, as I discussed previously, that wasn't the case. And that wasn't the case more evidently in the TNE context. Why do I say more evidently? Because these challenges also do appear here in Leeds as well. It's not just for TNE international students, but also for UK home students. So language plays several critical roles, even in mathematics, in terms of terminology and communication. So due to the nature of the program, language is a learning outcome in my module. And now I have a better idea of how to achieve this. So there is a need to embed the language of mathematics within my lectures. So I've started asking myself, what terminology do the students don't know? What do they struggle with? Are some terms more difficult or easier for them? And students have asked for some pre-work on the mathematical language to prepare them for the lectures ahead. And because of that, I've started spending the first 5 or 10 minutes of each of my lecture focusing on the language that we will see in that particular lecture. So through diagrams, texts, and some micro dialogues to help them with communicating mathematics.
Great stuff. And my own narrative will echo what Kostas has just reported, which I think is of note in itself. So what I learned I could do effectively and usefully early on was to draw on diagrams of various kinds, diagrams primarily of geometrical objects, let's say, or graphs, the various diagrams, there are many, of course, that mathematics uses, and to use those to anchor discussions around and teaching of mathematical technical terminology, i.e. the meta-language of mathematics. So that was a very early observation for myself, and that's grown over the time. I've been able to develop a suite of ways into supporting students, I believe, effectively using diagrams of whatever mathematical phenomena is under discussion, and to embed terminology in and around that. So as Costa said a moment ago, terminology is absolutely a front and center concern, I would say, in the academic English world of mathematics. Second bullet point. My initial assumptions about the density and complexity of mathematics texts remain true. Mathematics text is dense and complex, but it turns out that mathematics enjoys presenting itself in lots of different formats. Indeed, there are some popular mathematics publications out there, one of which is Chalkdust. You may want to explore that on chalkdustmagazine.com. It's a student PhD produced magazine that comes out of UCL in the UK and contains mathematics articles, but they are bit more accessible, lots of diagrams with them. It's an interesting form of mathematics writing. Numberphile is a YouTube site that you may wish to explore. Mathematics associations produce lots of different texts. There is writing in book form, popular mathematics writing. So mathematics, it turns out, tells its own stories in many genres. And I've integrated, when I came to understand this in the role that I inhabit, I was able to draw on that, I believe, again, successfully and effectively in terms of using these these genres, these forms of writing for supporting students. Okay, of course, dissertations tend to take a fairly standard approach, let's say, across the disciplines. I think mathematics can be a little bit of an outlier in some respects, but of course, dissertations still have a similar kind of structure and similar kind of argumentation, and that was a part of my development, of course, learning how to work with those when there's a fair crossover from other disciplines. I'll drop to the fifth bullet point. There is some essay writing in the discipline of mathematics, certainly at this university, and I think more widely. So that was a bit of a surprise to me, I think, perhaps some years ago, but of course that is the case, and other forms of writing are used as well, some reflective writing in certain contexts and others. So this is all, a little bit more familiar, and that was useful in giving myself a degree of a purchase, let's say, in the discipline, and developing my understanding of the whole world of mathematics, writing, communication, and of course the socialization side of things into the discipline in various ways. So what came out of this sort of rapid development, let's say, were a number of initiatives here. We have a first year provision, which is a 4-seminar provision to AL students in semester 1, which helps to orient students to the mathematics and to the language and to the communication expectations of their journey. We have work delivered into UG and PGT dissertations, PGT kind of skills module support, various different modules where work is delivered from myself in consultation with and working alongside lecturers, consultations, and so on and so forth. So all of that sort of bit has built over the last several years to create quite a very rich suite of provision. So that the takeaway, of course, from that is, just as Kostas said from his own context, that it does turn out that the interface between language and mathematics is rich, multifaceted, and that both the maths and the textuality, the language, the technical terminology, the communication are part of a student's journey within this discipline. I also studied quite a lot of mathematics and that was, of course, beneficial. Okay, so I think that takes us to part 1C, which we're calling, as we're calling it. Kostas and I encountered each other through a mutual colleague a bit over 2 years ago, and now we'd like to talk about how that connection supported each other and developed what we were doing in our respective contexts, and then later together, and we'll turn to one example of that shortly. So staying with myself, once we met, we spent a few, we'll just go back one slide. Yeah, so it was sort of a one-off meeting was the original sort of deal here, which was let's meet up and have a chat, and we did. And it turned out, as I recall that discussion, there was a heck of a lot to say. So it was a long discussion about the nature of mathematics, the nature of the academy, the nature of UKHE, the nature of language in its manifold manifestations. And it very quickly became apparent, I think, that there were things that we could do and think about together, things we could inform each other on from our sort of different perspectives. So what are some of those things? Well, we created a suite of video materials that remain in use for students. That's our first bullet point. So in working together, we put that stuff out there. We were able to select certain parts of mathematics that we both understood. Kostas was perhaps the lead, of course, on the mathematics, and then put them create texts, extracts of texts, and markup of texts that were supportive to the UG students. Second bullet point, there was a lot of just chat and talk. I don't think we should underestimate the role of what we've called here mutually supportive discussions across the disciplinary divide, if divide it is. Okay, so from a mathematician and an EAP practitioner, quite distinct ways of looking at things perhaps, but it turned out, and it continues to turn out, that there is a lot to say to each other from those two distinct perspectives that is mutually developmental, mutually informing, and creates win-win synergies. We have written together, I mentioned Chalk Dust magazine a moment ago, we have submitted a co-written article on that to that publication, yet to appear, but hopefully coming soon. You can read that maybe in September when the next issue comes out. And we also have, when time allows, we have a number of initiatives in the background for quite lengthy pieces of writing, we think, some of which are listed there. And we've done a number of presentations together. You may have seen us at Barleap last year and in other arenas. So that's some of the various kinds of work, from simply talking through to sort of more kind of heavy or outputs of various kinds. And there's been a lot that I, speaking for myself, have gained from that's been beneficial. I hope the same is true for Kostas, but certainly academic identity practitioner level, my mathematics is better, my understanding of the discipline is better, how it works, and of course, therefore, my understanding of the integration of language and text and EAP matters into that discipline. The level of scholarship, as I've said a moment ago, we have presented and indeed are presenting today, so that's been beneficial. In terms of the students, who, of course, for whom, of course, we are doing all of this, there has been that output with various materials of various kinds. And as we'll come to shortly, along with Shui Chen, we have a book in progress, a student-facing open access book, The Academic Language of Mathematics. So I think this has been chat and talk, but not just chat and talk. Things have occurred, are occurring, and will occur. Back to Kostas.
Perfect. So, yes, the academic language of mathematics. So where did this come from? As I mentioned earlier, the students, I've been spending the first 5-10 minutes of my lectures delivering some content on the language of mathematics to prepare the students for the lecture ahead. And getting some feedback from the students were asking for more of this content in a more structured way. That's one thing. And Dick has always been saying that we should write a book about this. So when the opportunity came through the Leeds University's open book program, they've put out a call. We thought this was a perfect opportunity for us. And thankfully, our proposal was successful. And here we are. We are writing now the academic language of mathematics. This is an open access web book, and we hope that it will be launching soon in the summer. It is an online web book, meaning it's basically a website. It's open access. Anyone will be able to access it throughout the world. We aim for this book to be used by, first of all, students as a self-study resource. Second, by lecturers in mathematics like myself, spend the first few minutes of each lecture to focus on the language ahead and prepare the students. And thirdly, by EAP lecturers, because once we give all the answers and all the keys of how to pronounce all the mathematical equations, how to read them out, then language specialists can focus on the pronunciation, the collocations, and these sort of things, and perhaps more. So this is an 8-chapter open access web book. And the idea of it is not to help students with the content of the course of mathematics, but more with the language of mathematics and make them better communicators. It has 8 chapters and they are based off my module. So this was a prerequisite for the Leeds Libraries open book program to be modeled after a module. So it follows my module,